Okay, hi again there, grade 11. I hope you had a nice break. We're going to continue with the last stages of our chapter 5 topics. We've been dealing with linear models. We learned how to find the equation of a straight line given 2 points of input, and then we extended that to ones which were called direct proportion, and that was when one of the points guaranteed in our table was 0, 0. These were common with currency conversions for conversions between miles per hour and kilometers per hour, and weights like kilograms and pounds. Anyway, we're going to continue today, and this is the last sort of phase of the problem of the chapter, and it's going to take two mini topics to get through it. This first one is going to be when we have two linear models, what does it mean to find the intersection and how do we interpret those results? So we're going to get started here, and we're going to be dealing again with these linear models from chapter 5. Go ahead and read this. In some situations, we may have several equations that must all be true at the same time. We call these simultaneous equations. That's because they're all happening at the same time. To solve simultaneous equations, we require values for the variable which satisfy each of the equations. These values are the simultaneous solutions to the equations. So we're looking for where the straight lines cross. And there's ways to do it graphically, and there's ways to do it algebraically, and best of all for us, there's ways to do it electronically with a great macro on our calculator. So the first thing I want to do is show you a graphical technique. Some of you may recall that when you were younger, you were often asked to graph straight lines, and they were of the form y equals mx plus b. And I've done just that here with this first problem A. It says y equals x minus 2, and it also says that y equals negative 2x plus 10. If I graph them, you can see that the blue one is here and the red one is there, and they cross here. Now, it looks pretty convincing that those two lines cross at the ordered pair 4, 2. I suppose on a microscopic level I might be off a little bit, but it looks pretty darn close to there, and it's so close that I'm prepared to sign off on that one. I did this particular solution on Desmos, which is not something you have access to on assessments of any kind. You do, well, I suppose technically your internal assessment, your course project in grade 12. So I'm going to show you a different way to handle it. And let's watch this little video here that I made. We're going to start by making a new calculator. And this one's particularly useful since these equations, y equals x minus 2 and y equals negative 2x plus 10, were expressed in the conventional y equals mx plus b format. And so we can enter them as functions on here. So type in negative 2x plus 10, and we will get a good look. I'm going to move those labels around a little bit further away. And if I wanted to find out where they cross, there's a macro for that. We go into menu and we do analyze the graph, number 6, and we can look for option 4, where do they intersect? And we take this line, and it's called the lower bound, and we try and position it to the left of where we can see the intersection is. Then the command changes to upper bound, and I click on the other side of the intersection, which is to say to the right of it, and you can see there that they found that the location of the intersection is indeed 4, 2. Now that's pretty handy to have the calculator doing that for us. But there's even still another way to do it. And I'm going to go back to, they're going to show you that there is what we call a system of linear equations or simultaneous equation problem solver on our calculator. And here's another little video of how that works. You could go to, since both these equations actually reminds me y equals something and y equals something else, you could go back to our old friend nsolve and just set the definitional sides equal to each other. So x minus 2 must equal negative 2x plus 10. Don't forget we're saying we need to solve for x, comma x, and you can see that the answer is 4. But now that just solves for x. We want to know what x and y both are, so I would have to work it out. And by simply substituting in 4 into one of the two equations, and I took the first one, x minus 2, and I got that answer there. Now, the other thing I could do is go to the second option, which is solving systems of linear equations. Now, I like this one because you can change the number of equations that you want. You can change the variables that you want. And you also don't depend upon the equations being laid out as y equals mx plus b lines. It can be any format, but they happen to be, so I'll just type them in. And here, not only does it provide for me that x is equal to 4, it also provides that y is equal to 2. So it's like one-stop shopping. Everything is done in one shot, and you don't have to do any touch-up. So this probably is a superior technique to the other ones. It also doesn't depend upon the graph being positioned in a way where you can easily, accurately see where the intersection is. So this might be the way to go forward. Okay, let's see what we have here. Now here's a couple more. Y equals x minus 3. And this is exactly what I was just referring to. That the equations are not all designed as y equals mx plus b equations. They're linear, meaning both x and y are only attached to each other by addition or subtraction, and they all have got the exponent 1. That's basically the definition of to be linear. So what are we going to do? All right, I'm going to get my calculator out, and I'm going to use that special app. And I'm not going to graph it because they're not convenient for graphing. I'm going to go to algebra, and I'm going to solve system of linear equations. It's two equations, x's and y's are the variables, and I'm just going to type them in exactly as I see them, and that's in the upper corner there. X minus 3, 2x plus y equals 12, and hit the equals, and it will tell me that x is 5 and y is 2. Hey, just for the sake of practice, let's do the other ones now. Two variables, up one, two equations, two variables, x and y. X equals y minus 1. That's a very unconventional way to phrase the problem. Doesn't matter to us, doesn't matter to the calculator. 4x minus 3y equals 0. And it tells us that the answers are 3 and 4. So if x is 3 and y is 4, that middle set of equations is solved. And the final one, also slightly unconventionally designed. System of linear equations. Two equations, x and y are the variables. And I'm going to type them in here. Y equals x plus 6, and 3y plus 2x is 13. And it tells us that the answer is -1 for x and 5 for y. Okay, let's move on here. Now we're going to solve some word problems. This is where students sometimes struggle. And if you want to, you can hit pause and try to do this yourself first, and then you can watch my solution. I'll tell you when I think you should pause if you want to try that. A hairdresser has 13 small and 14 large cans of hairspray, giving a total of 9 liters of hairspray. So I guess the contents of those cans would add up to, if it was possible to do that, to 9 liters of hairspray. At this time last year, she had 4 smalls and 12 large cans, so a different quantity of each, and it totaled a different quantity of hairspray, which was 6 liters. So how much hairspray is in each size can? I like to visualize these problems. I find most students who fail to answer them actually fail to get started. They're hesitant to even write anything down, and I'm quite happy to make a little visual display out of it and think of it. So I got 13 small cans and 14 large cans there, and that was equal to 9 liters. And so I've turned it into an equation. Now notice that the variables I chose are little s and capital L. I didn't use a small l because small l's often look like ones when you're typing them out. So you don't have to. You can call them x and y. That's absolutely fine. But I would suggest that you write down which letter you use to represent which quantity, because it's quite easy to forget when you're solving the problem. If I change the number of cans, I'm going to get 4 smalls and 12 large with 6 liters, and so similarly to the last case, I'll go ahead and turn that into an equation. 4s plus 12l is 6. Now you may want to stop and do this on your own now, or you can follow my solution. I'm going to say algebra, let's solve some linear equations. I'm going to change my variables here to, no, that changed. I'm going to change this to S and L, small s, capital L, and that's what it's expecting me. So 13 smalls and 14 large is 9 liters, and 4 smalls and 12 larges is 6 liters. And it will tell me straight away that the small is 6/25, and the large is 21/50. Now, what you can do is you can change your answers to decimal form. If you weren't sure how I did that, we can go ahead and I'll show you in class. You could tell on the last couple minutes of the seconds of the video that what keystrokes I did to get that. So that means it's 0.24 of a liter for the smalls and 0.42 of a liter for the large. Okay, another one here. A violinist is learning a waltz and a sonatina. Is that a word? Anyway, one day she practices for 33 minutes overall by playing the waltz 4 times and the sonatina 3 times. The next day she plays the waltz 6 times and the sonatina only once for a total of 25 minutes. So once again, now it's hard to make a picture of this, but I think we can sensibly let the duration of the waltz be W and the duration of the sonatina, whatever, is S. And that turns into these 2 equations here. 4 waltzes and 3 of the other ones is 33 minutes. 6 waltzes and 1 of the other one is 25. And then we're off to the GDC. If you want to go ahead and do that one on your GDC, that's fine. I'll come up with an answer and we can compare in class. Shop sells 2 lengths of extension cable. Thomas buys 2 shorts, 5 longs for a total of 26 meters. Alicia buys 24.3 of cabling total by having 3 short and 4 longs. Okay, I'm going to allow you to try and solve that one. I'll have a solution for you as well, and we can compare those. And where does that leave us now? My laptop is frozen. Okay, I had some sort of weird hiccup in there. I've got it restarted. I hope this is playing properly now. 2S and 5G, I've called G longs. I didn't want to get into the 5L, looks like a 51. And 3S and 4G, G for long, is 24.3. So I've deduced that from the wording of the question. And I can continue now, and it says that very, very slow. I don't know why my here we go. And we can see now I'm going to use my equation solver, menu, algebra, solving systems of linear equations, and we shall get 2 equations. The variables are S and G, S comma G, and so we're looking for that information on the next screen, and I just type in the information that's in that blue rectangle in the upper left corner. 2S 5G is 26, and 3S and 4G is 24.3. And I can see, therefore, that the short cable is 2.5 meters long, and the long one is 4.2 meters long. And let's see where that takes us now. Last question we're going to do together. In an archery competition, competitors fire 8 arrows at a target. They are awarded points based on which region of the target is hit. The results for 2 of the competitors are shown. This is kind of a cool question because you're going to have to look at the diagram and deduce what they're talking about. So in the first one, I would say some of them are going to hit the red region. So there's certain points for the red, which I think are probably higher because it's near the middle or nearer to a bullseye. And the blue one is the outer ring. Okay, so we've got, in the first case, let's see, 5 reds and 3 blues. In the second case, it was 2 reds and 6 blues. And so I've changed that into equations. 5 reds and 3 blues was 68 points. 2 reds and 6 blues was 56 points. And that, friends, that's simultaneous equations right there. So back to the calculator we go. And is it going to start on its own? No, it's going to start now. Here we go. Menu, algebra, solve systems of linear equations. I'm going to change those letters to R and B, not to be confused with R and B. 5R and 3B is 68. 2R and 6B is 56. 6B is 56. And it tells us that the red ones must be 10 points and the blues must be 6 points. So well done to those archers for getting all those points. And here we are. We're into the exercise set now. 5F. The questions are... this is our second last exercise set from Chapter 5. We will be testing soon on financial applications and also linear models and now simultaneous equations or systems of equations. And we've got one more mini topic to go next time. And here are our questions from Chapter 5, and we're in Section 5F. Questions 1, 2, 3, and 4. If you've watched this video and you've got time to do these in class, you should do it. And you can get my help. You can get my help with your calculator, with interpreting the wording of the questions, inputting information, and understanding solutions. Okay, that's all very positive. I look forward to helping you in class.